Welcome back to another episode of Studysmart. In our previous video, we solved a sample problem on some basic roots of an ODE. Right. In today's video, we are having another sample problem to illustrate further the other two um, cases when the roots are imaginary and when the roots are repeated. Alright. So the first question, we have two sample problems here. Solve the equations the cube y as the cube y over dx cube plus 6d square y over dx square plus 12 dy dx plus 8y equal to 0. Now if you notice this problem, we were not given initial conditions, that's boundary conditions. Means that when solving this equation, because we are not given boundary conditions, we will only end at the auxiliary equation. Right, so let's analyze this problem. Solution of this problem starting from question 1. Alright, so the question 1 there is the cube y over the x cube, then plus 6 the square y over the x squared plus 12 dy dx plus 8y equal to 0. Right, so we are going to assume y to be equal to exponential mx. From the initial video, I explained this. Right, so the highest power here is 3. So we are going to differentiate the value of y here 3 times. Alright, so we are going to look for dy dx to be m exponential mx. We are further going to look for the square y over dx squared, which is going to give m squared exponential mx, and then we are going to look for the cube y over the x cube, which is going to give us m cube exponential mx. Right, so we've known y dy dx, the square y dx, and the cube y dx. We are going to substitute to the expression. So substituting, we are going to have the cube y, which is this. So this will be m cube exponential mx, and then we have plus, there's 6. We have 6 the square y over dx square, which is this, to be m squared exponential mx, and then we have plus 12 the dy dx, which is this. We have m exponential mx, and then we have 8y plus 8y exponential mx. Y here is exponential mx. Right, so this is exponential mx, and all is equal to 0. Right, so this is the new expression we have. So if you check very well from this expression, mx exponential mx is common. I will factor out exponential mx, and I will have m cube plus 6m squared plus 12m plus 8. Alright, so equal to 0. So provided that mx is not equal to 0, the expression we are going to solve it. Right, we are going to solve this the polynomial to the third power. So we'll pull it out, m cube plus 6m squared plus 12m plus 8. Alright, so equal to 0. Alright, so we are going to assume values because this is polynomial to the third power, and then we need to solve this thing quadratically, but it's not in power 2, so we need to deduce it. So how do we deduce this? So we're going to assume a value such that when you substitute it to this expression, it should give you 0. So we are going to assume a value such that when I assume that value and I substitute the value to this expression, it should be able to give me 0. So let me say my f of m here becomes this expression, right? So it will be m cubed plus 6m squared plus 12m plus 8. Alright, so my f of m now, I can assume cannot say assume, right, f of m here, f of m is equal to f of minus 2, which means that m here is equal to minus 2, right, which means m here is equal to minus 2. So I'm going to substitute minus 2 into this expression. So this will give me f of minus 2 to be equal to, I'll have here minus 2 cube plus 6 into minus 2 squared plus 12 into minus 2 plus 8. Alright, so f of minus 2 here will give me, this will give me minus 8, because minus 2 to power 3 is minus 8. I have this will give me, this is going to give me plus 6 into minus 2 raised to power 2 will give me 4. Alright, so plus 12 into minus 2 plus 8. Alright, so this expression will give me f of f of minus 2, f of minus 2 will be equal to, so this is going to give me minus 8 plus, right, so 6 times 4 here is going to give me 24. I have 12 times minus 2 here will give me minus 24, and I have plus 8. Alright, so if this cancels out this cancels out this, alright, the answer here will give me 0. Alright, so it means that from this point, from m equal to minus 2, it means that the value I assumed is m plus 2, because since m here, since assumed value, right, since assumed value is m equal to minus 2. So if I move this 2 over to this point, I'm going to have m plus 2, right? So this m plus 2 was the value I assumed equal to 0. So I'm going to use this assumed value here, and I'll perform a long division with the expression, this expression, right? Perform a long division with this expression in order for me to obtain a quadratic equation, right? So I'm deducing it now. So I'll have from long division m plus 2. I'm going to bring back all my expression. It should be m cubed plus 6 m squared plus 12, and I have plus 8, right? So this is how it works. This is m and this is m cubed. So I'll start by dividing this divided by this will give me m squared. So I'll still use them to multiply this again. So this times this now gives me m cubed. Then 2 times this gives me plus 2m squared. Alright, so this is what I have. Then I'm going to minus it. This minus this here will give me 0. This can go, gives me 0. So plus 6 minus 2 here is going to give me 4m squared. So I'll have to repeat all these values. This is m, sorry. This is going to give me plus 12m plus 8. Right, so I'm still going to do the same thing here. I'm still going to divide this by this. So m divided by 4m squared will give me plus 4m here. Now I multiply again. This times this here gives me 4m squared. This times this here gives me plus 8m. Alright, so perform another long division here. I'm going to minus again. So this will give me 0. Alright, so 12 here, 12 minus 8 here is going to give me 4m. I still have my plus 8 here. I'll perform another one again. I'll divide this again by this, and I'm going to have 4. And 4 times this is still going to give me sorry, this is 4m. Then this times this again gives me plus 8. So I'll perform another subtraction here. This minus this gives me 0. This minus this gives me 0. Alright, so the new expression for the equation to power 3 we got, this expression can now be written in the form. I'll bring out this point here, m plus 2. I'll bring out this point here, m squared plus 4m plus 4, then I will equate it to 0. So this is my new expression, and I'm going to solve this expression, the expression I'm going to use now. Right, so this is my new expression I'm going to use. So my m plus 2, so from this case now I have a quadratic equation, then you have to solve this one quadratically now. Right, so you have to solve this quadratically. So the cheat I gave you, you look for two numbers that such that when you add those two numbers, or when you multiply those two numbers, it should be able to give you 4, and when you add them here, it should be able to give you this also. Excuse me. So those two numbers I have, if I have plus 2 and plus 2, right? So it means that if I add plus 2 here, if I add plus 2, it should give me 4. If I multiply plus 2, it should give me 4. So I have m plus 2 here, and also have m plus 2, right? So this will give me 0. Like I said from our initial video, I made clarifications that when you have a plus recall, and when you have a plus b and b plus a here equal to 0, means that a plus b is equal to 0, or b plus a is equal to 0. Alright, so that's what it means. So we are going to apply this initiative here to this particular expression. So it means that m plus 2 is equal to 0, and m plus 2 is equal to 0, and also m plus 2 is equal to 0 here. That's what it means. Alright, so I'm going to look for the value of m. This is m1 equal to minus 2, and then I have my m2 equal to minus 2, and I have my m3 equal to minus 2. So right, so this satisfies one of the cases I gave initially from a previous class. Right, so I gave a condition for when the roots are real and repeated. So right, so this is a real root, but if you check very well, they are repeating. I have minus 2, I have minus 2, and also have minus 2. Right, so I have minus 2, minus 2, minus 2, so they are repeating. So you can just indicate here by saying, since roots are real and repeating, you are going to recall that since for a real and repeated root, I give you an expression that y is equal to c1 exponential m1 of x, then plus c2x exponential m2x, and then plus c3x squared exponential m3x, plus to the point of cn xn exponential mn of x. All right, so we have only two power 3, we have only 3 roots here, 1 2 3, so I'm going to have the c's to 3. Right, it means that y here will be equal to c1, right, exponential my m1 here is minus 2, so I have minus 2x plus c2x exponential my m2 here is 2, I have 2, that's minus 2, sorry, this is minus 2, right, so this is minus 2x, and I have plus c3x squared, and I have my m3, which is minus 2 also, so exponential minus 2x. Alright, so this becomes our answer. So I can just factor this by saying that y is equal to, I have c1, so the most common thing here is exponential minus 2, so I can factor out exponential minus 2 out. So exponential minus 2x into, so when I cancel out this, I have c1 plus, when I cancel from here, I'm going to have c2x and then plus c3x squared, and this becomes the answer to the given solution. Right. Alright, so this is the answer for question 1. So let us go dive into question 2. So question 2, solution number 2. Right, so what's the question? We have that the 6y over the x to the power 6 plus 3 the 4y over the x to the power 4 plus 3 the square y over dx to power 2 plus y equal to 0, right? So we are still going to use the same ideology we did from the initial one, right? So we can assume y to be equal to exponential mx, alright? So the highest power here is 6, so I'm going to differentiate this to the 6 times. So I'm going to have my y, my dy dx here to be equal to like I said before, in differentiating this, you just take the m multiplied by this whole expression, right? So this is m exponential mx, right? So for the square y dx here, dx square, I'm going to have m squared exponential mx, right? So for the 3y over dx power 3 here, I'm going to have m3 exponential mx here. Then for the fourth derivative, which is the 4y over dx to power 4, I'm going to have m to power 4 exponential mx here. Then if I'm differentiating to the fifth power here, I'm going to have m to power 5 exponential mx. If I'm differentiating to the sixth power, dx to power 6, I'm going to have m to power 6 exponential mx. Alright, so we've known from y down to the sixth derivative. So I'm going to substitute everything here back to this expression. Alright, so the sixth power here we had was this. So I'm going to have m to power 6 exponential mx. Then I have this 3, this plus 3. Then the fourth power, which is this, m to power 4 exponential mx, then plus 3. Right, so the square over dx square is m squared exponential mx, and I have plus my y is exponential m x equal to 0. Alright, so exponential mx here is common, so I'm going to factor it out. I have exponential mx here to be m to power 6 plus 3m to power 4, right? So plus 3m squared, right? 3m squared. So I'm going to have m squared, and here will be 1, right? So this is equal to 0. So provided that exponential mx is not equal to 0, this expression, right? So this is what we obtained: m to power 6 plus 3m to power 4 plus 3m squared plus 1. Alright, so the root of this equation is expressed in the form of, so if I want to factorize this expression, alright, so it can also be written in the form of m squared plus 1 equal to 3, to power 3 equal to 0. Right, so m squared plus 1 to power 3 equal to 0. Right, so if I expand this expression, if I factorize this expression, I will be able to obtain this expression here. If I factorize this expression, I should be able to obtain this. Right, so at your convenient time, you can just expand it to check. Right, so but if you expand this expression, m squared plus 1 to power 3 should be able to give you m to power 6 plus 3m to power 4 plus 3m squared plus 1. Right, so this is to power 3, means that this is appearing 3 times. Alright, so this is m squared plus 1 equal to 0, m squared plus 1 equal to 0, and m squared plus 1 equal to 0. And so I'll have to move this one over this way. I'm going to have m squared equal to minus 1, and I also have m squared equal to minus 1, and m squared here equal to minus 1. Alright, so if I take the square root of this, therefore this is 0, so I can say m squared is equal to 0 minus 1. So I see the same thing. So m squared here also 0 minus 1, and m squared here 0 minus 1. So this and this is still the same thing. Alright, so If I take the square root of this, I'm going to have, let me just put it down there, m equal to 0 plus minus 1, m equals 0 plus minus 1, and m equals 0 plus minus 1. Right, so I can say, let a here equal to 0 and then b equal to 1. Right, so from here, this is I. Right, so sorry, if I take the square root of a negative value, I'm going to obtain I. So this is plus minus I. Right, all these things are I. This is I. This is I here, and this is I, and also this is I. Right, so this is I, because root minus 1 is same thing as I. If I take the root of this, I will obtain root minus 1, and root minus 1 is I, so which is plus minus I. Right, so this is I. All these things are 1, they are I. Alright, so A equal to 0 and B equal to I. Right, so since if you check very well, the roots are imaginary and repeated. Right, so they are imaginary and repeated. So I give a condition for when the roots are imaginary and repeated. Right, so that condition, so since roots are imaginary and repeated, I give a condition that y is equal to c1, right, exponential. Right, so since we're using a and b here, let me just change that to ax, then cos bx, right, so plus c2 exponential ax, exponential ax, then x cos bx plus c3 exponential ax sine bx, and then plus c4 exponential ax sine, this is x sine bx. Right, so if you check very well from this expression, we have up to 3 roots here. This is 1, 2, and 3. Right, so I'm going to have this up to 3. Is that I'm going to have this up to 3. So this is going to give me y equal to c1 exponential, my 0, my a here is 0, so this becomes 0, I have cos, right, cos b here is 1, so this is x, and plus c2 exponential, this is 0, this is x, and I have cos, my b here is 1, this is x, and I have plus c3 exponential 0, then x increases to 2 cos x, that's for cos, then I go over to sine, plus c4 exponential 0 sine x, plus c5 exponential 0 x sine x, and then plus c6 exponential 0 x squared sine x. Right, so my y here becomes, this is exponential to power 0, which is 1, so this is going to give me c1 cos x plus c2 x cos x plus c3 x squared cos x, then plus c4 sin x, and then plus c5 x sin x, and then lastly c6 x squared sin x. Right, so this becomes the answer to the problem. Hope you enjoyed the video. Share to your friends, comment, and don't forget to subscribe to our YouTube channel. Thank you.